Hello everyone, my name is Achref and I am excited to present our late-breaking work entitled VR-Surv, a VR-based privacy-preserving surveillance system. This work was done with Alejandro Sanchez, Guinea and Max Mühlhäuser from the Telecooperation Lab at the Technical University of Darmstadt in Germany. I would like to start the talk with the ethical dilemma that video surveillance systems keep encountering those days. On one hand, the continuous growth of urban environments imposes a wide deployment of surveillance systems to ensure security. On the other hand, this massive deployment presents serious challenges for privacy. Several techniques have been used to find an acceptable trade-off between the amount of information to reveal and to conceal. Using blurring filters and very low resolution videos are very popular techniques used for this purpose. However, this can be easily neutralized by using neural networks that increase the resolution of the videos. Other techniques rely on machine learning models to detect suspicious activities. However, this comes with certain risks, as the model's uncertainty may lead to false negatives or false positives. To mitigate the current problems, we propose to perform the video surveillance in a virtual environment, where changes on privacy-sensitive attributes can be done in a flexible and secure manner. In our implementation, we introduce intentional modifications to two visual scene attributes. First, the spatiotemporal context, and to do this, we use satellite imagery to build a virtual environment that's similar but not identical to the original one. Second, the identity of the individuals. For this, we perform a real-time pose estimation of all pedestrians in the scene and map this pose to 3D humanoids in the virtual environment. To evaluate the capability of our system to convey the semantics of the scene, we conduct a user study where 6 participants were exposed to situations that usually happen in the urban environment and asked them to determine those situations. The participants visualized the scene in VR-Surv and two other baselines, CCTV videos and 3D point cloud videos. For each participant, we calculated two scores, the average time needed to recognize the situation and the number of correct recognitions. The results of the user study revealed that the time needed to recognize the situation using VR-Surv is comparable to plain video baseline, meaning that VR-Surv is capable to convey the semantics of the scene as good as videos. For the recognition score, there was no significant difference between VR-Surv and the baselines. During a semi-structured interview, the participants showed more acceptance toward being recorded with VR-Surv. In this late-breaking work, we presented an early design and a preliminary evaluation of a VR-based immersive surveillance system. In the future, we plan to explore more visualization concepts and compare our system to more